So simplified DS is one of the another important symmetric cryptographic algorithm, which is also called as a private key cryptography. Again, with any cryptographic algorithm context, we are having three parts. The first part is the key generation process. The second is the encryption, and the last one is the decryption. So with the simplified DS is accepting 16-bit of plain text, 16-bit of the key, and it will be giving the 16-bit of ciphertext. So moving on with the this algorithm in detail. So this is the simplified encryption and decryption algorithm uh, in detail. So looking at the particular diagram, we will come to know that uh, three parts you will get straightforward, right? The very first part is the encryption process. The middle is the key generation process, and the last one is the decryption process. So you will understand the decryption is the reverse of encryption. So we will begin with the first key generation process. So here you need to note down that with the AES, with the 16-bit of input, the key generation algorithm will be giving the three keys of 16 bits, okay? And AES will be having two rounds for the encryption. But the keys will be three keys out of the key generation process will be generated. Okay, so looking at the key generation process in detail, so stay one by one we will discuss this particular steps in detail. Moving on with the first key generation process. So here we have considered the plain text. So D728, further if you convert that into the binary, it will look like this. So this will be our input, plain text of 16-bit and 16-bit of the key and their binary representation. And then this is the key generation algorithm. How many keys we are generating with the simplified AES key generation algorithm? So three keys we are generating. So very first thing into the key generation, what you have to do, you have to split that key, which is of 16-bit, into two half, right? Two half, that is W0 and W1, each one of 8-bit. So first 8-bit will be called as W0. The next 8-bit will be considered as W1. And then moving on with this, uh, we are having W0 and W1, and the equations are given over here. So what are that equation? It's given, right? Algorithm has defined that equation. So W2's equation is W2 is equal to W0 XOR with this R stands for round constant. So again, this constant has been defined by the algorithm itself. So round constant 1 XOR with substitute nibble, then rotate nibble W1. So don't worry, we will be trying to understand this function. So rotate nibble is nothing but four bit together is called as a nibble. So this rotate nibble operation is nothing but the swap operation, right? So we are going to see that swap operation in detail. That is nothing but like we are having how many nibbles, right? So in W1 we will be having right, W1 we will be having two nibbles, right? And that rotate nibble we have to perform. So we will see that how we can do that. Then round constant is nothing but the which is the constant defined by the algorithm itself. So it will be having the predefined value. So here you can see at the last round constant one, the value is 100 0 0 0 0, right? So this is fixed, which we will be using in the equation. And then substitute nibble. So as we have used substitution boxes in the simplified DS, in similar way here we will be using substitution box. Again, substitution box is defined by the algorithm itself. We are not uh, creating the substitution boxes. So if you look at the substitution box, the values has been 4 by 4 matrix it is there, and the values are defined over here, right? So then next, what we have to do, we have to first perform rotate nibble w1. Okay, so w1 value, this is the w1 value, what it is, 11110101. So this is nothing but just shifting first with the second, right? Shift, swapping this two nibble with each other. Once you are done with the rotate nibble, then comes the substitute nibble operation. So in the substitute nibble operation, I need to elaborate that in detail. So I'll be using the board over here. So here, try to understand how the, I hope the S box is visible to you, right? So in substitute nibble, let's say, I hope rotate nibble is clear to you. Rotate nibble is nothing but just shifting of, uh, let's say, right? This is the first nibble and this is the second nibble. So swapping these two nibbles with each other is nothing but the substitute nibble. So uh, after substitution, we will be getting uh, like we done the substitution nibble of initial input, that is our W1, right? W1. So this was the W1. W1 was 1101. After the swapping of W1, we will be getting this. After the swapping, that is nothing but the rotate operation. We will be getting this, right? And then comes, we done with these steps, right? Rotate nibble. And then we are looking for the substitute nibble. In the substitute nibble operation, what you have to do, this is something which is the input, right? So what you have to do, you have to, for 0 nibble substitution, so for 4 bit we will be substituting that 4 bit with some another 4 bit value. Okay, so for 0 1 0 1, that is the first nibble, what value we are going to substitute? So for this, we need the substitution box. Okay. For this, we need the substitution box. So you have to consider the value. This is the 0 0 0 1 1 0 1 1. So here 0 1 0 1. This 2 will be row and this 2 will be column. Right. So 0 1 0 1 and 0 1. The value we are getting is the 1, and then what you have to do, you have to represent the 1 into the binary format. So that is nothing but the substitution operation. So binary value for the 1 will be 0 0 0 1. In similar way, we have to do substitution for 1 1 1 1. So 1 1 and 1 1. The value we are getting is 7. So 7, we will be substituting the 7 value for this nibble. So this is nothing but the substitute nibble operation. I hope substitution operation is clear to you. And then the round constant is defined by the algorithm which we will be using. So moving on, um, so this is the straightforward equation. W2 is equal to W0 XOR with round constant 1 XOR with substitute nibble, rotate nibble W1. So once you are done with that, you will be getting the W2 value. So just look at the example. Here W0, W1 is given. Round constant as I have mentioned, that is 10000000, and after rotating the W1 and then performing the substitution, we will be getting this value. And again, once you are doing that XORing all these three uh, arguments, you will be getting the final value as 1101 1101. So that will be the W1. Then moving on, the W3 equation is, again, all the equations are defined by the algorithm. So W3 equation will be W2 XOR with W1. Very straightforward equation, right? So both the values are available with us. W2 we have generated with the putting the values into the equation, and W1 we are already having. And XORing that two values will give you W3 value. So I hope that, you are very much clear with W3 as well. So now we are having W0, W1, W2, W3, right? Now we need to generate W4. So for generating the W4, I'll be using the board again. I hope this is visible to you. So for W3, the equation is okay. So we are done with W3. Now the W4 equation is W2 XOR with round constant 2. So round constant 2 is, I'll write here round constant 2, that is 0011 0000. That is the round constant archon 2. Okay. Archon 2. So it is defined by the algorithm itself. So for this is the round constant 2. For you only, what I'll be doing, I'll be writing the W4 equation. Okay. So W2 equation we are having. I'll one more time I'll write the equation. W2 equation, what the W2 is, W0 XOR, okay, XOR with round constant 1, right? Then XOR with substitute nibble, rotate nibble, W1, right? W1. In similar way, we will be performing so now this is the W2 equation, right? And if we want to write the same equation for the W4, so W4 equation in similar manner will be W2, right? W2 XOR with round constant archon 2 XOR with substitute nibble rotatable W3, right? W3. That will be the equation in line with W2 XOR with round constant 1, W2 XOR with round constant 2 XOR with substitutable rotatable W3. So putting the value round constant we have discussed, right? So that round constant is 0, 0, 1, 0, 0, 0, 0, 0. Putting the value in the equation, we will get W4. And the W5 is straightforward, W4 XOR with W3. So I hope like you are clear with W0, W1, W0, W1, W2, W3, W4, and W5. Now we are ready with all the values, and then the last step which we have to do is just concatenation. So we will be concatenating. To generate the 3 keys, we need to do the concatenation. Okay. So let me show you how you will be doing concatenation. So these are the concatenations which you have to do for key generation. The first key will be W0 XOR W0 concatenated with the W1. The second key will be W2 concatenated with W3. And the next key will be W4 concatenated with the W5. And here we are ready with 3 keys of 16-bit each. So that will finish our key generation algorithm, and then we will be starting with the next encryption algorithm.